Section 14.5, Equations with Radicals. In this video, we're going to learn to solve equations that contain one or more radical expressions. So let's start by looking at some general steps for how to solve equations with radicals. So what you want to do is, if you only have one radical, you want to isolate that radical on one side of the equation. If you have more than one radical, you actually want to get one radical on the left side and another radical on the right side. Once you separate your radicals, what you want to do then is raise both sides of the equation to the power that corresponds to the index. So if you're doing a square root, you're going to want to square both sides. Or if you're doing a cube root, you'll cube both sides. Then after you raise both sides and eliminate the radical, you're going to solve the equation like we've previously done. And then the last thing you want to do is check your possible solutions, because there will be a chance that you will get what's known as an extraneous solution. And notice that this has the root word of extra. And what happens is these are numbers that when you do the algebra will come out as a possible solution, but then when you substitute in will not make the equation true. Those are very typical to show up with radical equations, so make sure you check all your answers. So we want to solve our first equation. We want to make sure that we have our square root isolated on one side of the equation, which we do. We have a square root equals and then our number. Now what we're going to do is we're going to raise both sides of the equation to the power that corresponds to the index. Remember that this is a square root, so the index is 2, so what we want to do is we want to square both sides. So when you square the square root of x plus 13, you just get x plus 13 equals, and then I need to square 7, which is 49. And now we need to solve by subtracting 13 from both sides, because we're trying to find what x would equal. Positive 13 and negative 13 would cancel, and 49 minus 13 would be 36. So now if I go back and substitute to double check this, I get the square root of x, which is 36, plus 13. I want to know, does that equal 7? Well, that's the square root of 49, and that's 7, and that does equal 7. So yes, I do have the correct solution. Now in our next problem, notice that our square root is not by itself. It's as a plus 2 with it on the left-hand side. So what we're going to do is we're going to start by subtracting 2 from both sides, because we want to get that radical by itself. So I get the cube root of 4 plus 3x equals, those have canceled, and 0 minus 2 is negative 2. And now we do have our radical isolated, so we're going to cube both sides. So I get 4 plus 3x, because the cube root being cubed will cancel and give me 4 plus 3x, and negative 2 cubed is negative 8. Now we want to get x by itself, so we'll subtract 4 and get 3x equals negative 12. Divide by 3, and x is negative 4. And now let's check to make sure that that makes this equation true. So I have the cube root of 4 plus 3 times negative 4, which would be negative 12, plus 2 equals 0. So that would be the cube root of 4 plus negative 12 is negative 8, plus 2 equals 0. The cube root of negative 8 is negative 2, and negative 2 plus 2 does equal 0. So we have the correct solution. In this problem, we need to isolate my square root first. So let's start by adding 8 to both sides. Just like if we were solving a regular equation, we want to get rid of anything added or subtracted first. Those will cancel, and we'll get 12. Then I need to divide by 2 and get the square root of x minus 4 equals 6. Now I need to square both sides to eliminate my square root and get x minus 4 equals 36, and then add 4, and x is 40. Now to do a quick check, 2 square root of 40 minus 4 minus 8 equals 4. So that's 2 square root of 36 minus 8 equals 4. That's 2 times 6, because 2 square root of 36 means 2 times 30, or square root of 36, minus 8 equals 4. That would be 12 minus 8 equals 4, and I do get that 4 equals 4. So our solution is that x is 40. In this problem, we already have our square root isolated, so we'll start by squaring both sides. So the square root of 2x plus 5 squared will be 2x plus 5. And negative 5 squared is 25, because negative 5 times negative 5 is positive 25. Now we'll subtract 5 and get that 2x equals 20. Divide by 2 and get that x is 10. So now I want to check that answer, and I would have the square root of 2 times 10 plus 5 equals negative 5. But that's the square root of 25, and the square root of 25 is 5. But 5 does not equal negative 5. So what that tells me is there is no solution to this, because the only answer that could have worked was 10, and it doesn't work because it didn't make the equation true. So this would be no solution, or we could say it was the empty set. In our last example, we actually have two radicals. So notice what we want to do is we want to get a radical on each side of the equation, and then we just raise to whatever the index would be. So we'll square both of these and get 4x plus 5 equals 2x plus 15. And now we solve this just like we did equations when we had variables on both sides. I'm going to subtract 2x to get my x's together. So I get 2x plus 5 equals 15. Then I'm going to subtract 5 and get that 2x equals 10, and divide by 2 and get that x is 5. Now I'll go back and substitute that in to make sure that it makes the equation true. So I want to know if the square root of 4 times 5 plus 5 equals the square root of 2 times 5 plus 15. But that's the square root of 25 equals the square root of 25. But that's 5 equals 5, and that's true. So our solution is x equals 5.